My name is Kyle Armour. This is Jordan Freed from Swirlds. You may know us from Hashgraph, Hadera. How many people know much about the algorithm? Raise the hands. Okay, we got some new people as well, so we're going to run through from the beginning. You guys, you guys want to come over? We're going to start real quick. Thanks. So again, my name is Kyle Armour. I'm a general admin. I kind of do all sorts of different things. Heavily involved in marketing and also fundraising for the company. This is Jordan Freed, VP of Global Business Development, who will be kind of running through some slides and telling you about the Hashgraph algorithm and kind of what we're doing with Hadera. So over to Jordan, a big mentor, inspiration of mine.
Thank you. Thank you everyone for being here. Before we kick things off, I want to bring up some folks from our community. So let's get the folks from Carbon.Money, Carbon.Money is I'll let them tell you what they are, but they're building on our platform and we're super excited to highlight them. Awesome.
So we are two of the team members from the Carbon team, and we're working on a unbacked stablecoin on Hedera Hashgraph. I was actually from the Hedera Hashgraph team initially, but we opted to build on top of Hedera Hashgraph because we believe the two biggest problems in the crypto space right now, the two things that are holding crypto back from expanding to the general economy, are throughput and volatility. And we believe that Hedera Hashgraph is the best solution we've seen so far to the throughput problem. And we hope to kind of be the volatility portion of that equation. So economists kind of view the three defining traits of money as being medium of exchange, unit of accounting, and store of value. And so far, cryptocurrencies have really only done two of those, arguably one.
Yeah.
And so we're hoping to kind of be the first cryptocurrency to hit all three of those, as well as kind of add a fourth trait, programmability, to the definition of money, because we believe that, especially as global economies get more complex, that programmability is going to play a much larger role in value transfer going forward. And we're hoping to kind of be the common denominator for the future of value transfer.
Yeah, and if you want to learn more, you can check out our white paper at Carbon.Money, and feel free to join our Telegram community.
Awesome. Carbon also just announced they closed the seed round of funding.
Yeah.
That's in the press release, right?
Sure.
Yeah, so they just raised $2 million, so congratulations, guys.
Yeah.
And, I don't mean to put you on the spot, but Brad, do you want to come say a few words on behalf of OpenCrowd?
Sure.
So OpenCrowd is one of our system integrators. They help do solutions and they build some stuff out. I think they're working on a few Hashgraph projects now.
Yes.
So Brad can tell you more about OpenCrowd.
Okay, so OpenCrowd is a design and technology solutions company. So a lot of times people come to us with their ideas, their white paper, right, or an enterprise, and we help to shape and build their solutions for them in a very iterative manner with them. So we've been working closely with the Hashgraph team and are very, very excited about this platform.
Awesome. Thanks for being here.
Thanks.
If you guys have questions on Hashgraph, you can talk to Carbon, you can talk to us, you can also talk to OpenCrowd. Their developers have some really deep experience with our SDK. So definitely go to opencrowd.com, check them out. Sorry for the shameless plugs. But who here, I want to measure the level of understanding we have about Hashgraph in the room tonight. Actually, I'm also going to give a shout out to someone else in the room quickly before we start. Dimitri Kofinas from Hidden Forces podcast is here. Dimitri really broke, he's one of the people who really broke the story on Hashgraph back when no one really showed up to our meetups except us. And Dimitri was a big part of that, so thanks for being here, Dimitri. And if you guys have any questions, he's had, what, 3, 4, 5 hours of Lehman time?
I know,
which is intense.
And Matt's time and Tom.
Exactly, so he's really, I would consider Dimitri one of the experts on the project as well, so thanks, Dimitri.
Yeah, thank you.
What's the name of the podcast?
HiddenForcesPod.com.
Hidden Forces, just Google Hidden Forces.
You find it.
You can also watch it on any United Airlines flight. Just like that as well. They're right in the directory there, so that's good.
Blowing my shit up, Jordan.
But okay, so back to measuring. Who knows what's the understanding of Hashgraph here? So who Who here feels like they have a pretty good understanding on how the Hashgraph consensus algorithm works? Okay, good. Who here has known about the project for more than 3 months? All right, cool. Okay, so what we're going to do then is we're going to run through some slides. We're going to talk about the consensus algorithm, but that's really technical. And for those that don't want to talk too technical, we'll really quickly get to, I'm going to blow through these. We're going to quickly get to what we're doing with this consensus algorithm and why we think it's going to change the entire internet and subsequently the entire world as we know it. So that's a big, bold claim, but we think that Dr. Baird has really made a fundamental breakthrough in computer science here, and I'm really excited to share this all with you guys and to really dive into detail on how it's actually being used. So first, we can't talk about Hashgraph before talking about Swirlds. Swirlds is the company that patented the Hashgraph consensus algorithm. Swirlds was created by Dr. Lehman Baird. He's the brilliant computer scientist and inventor, notable in that he holds, I think, the fastest PhD ever from Carnegie Mellon University. I believe we've even verified that.
Yeah.
2 years and 9 months. He's a remarkable individual that holds many patents personally. Mance is also very remarkable, more than 20 years in the deep tech leadership space, but Mance and Lehman met, and this is an incredible story for those that don't know it. Mance and Lehman met back in 1993, working for the senior scientists in the United States Air Force, doing research on machine learning. So these guys met back 25 years ago and have been working together ever since. The way they really got to know each other and got really close was by building what is now known as the Missile Defense Simulation Program, where we, the United States, and our allies simulate intercontinental ballistic missile attacks with the system that they were part of creating. So there's a good movie about that called War Games. You guys can check that out. But that's Mance and Lehman, really special individuals. They did co-found 2 companies. One was acquired by Symbol Technologies, subsequently acquired by Motorola. The other was acquired by a private equity firm, both in the identity space. Inside the company, we call them the Identirate, just because they just know so much and they're so passionate about identity. I think this is really important going forward with self-sovereign identity and what people want to use ledgers for. So that's a little bit about our founders. The technology, and going into the technology, I realized I also didn't introduce myself properly, but yes, I do run global business development for the company. What that really means, guys, is developer advocacy. So we build rapport and trust with companies and help educate them on what our SDK can do for them, and we help them integrate it into their technology stacks. So we have a team of developer advocates, that's on the business development team. And that team is building a suite of self-serving tools and resources like a curriculum platform, which I think I can announce now that we'll be releasing in the middle of May, where you can become Hashgraph certified. We made it so even my grandma could go get Hashgraph certified. So really anyone can do it, even the non-technical people out there, and learn how to use the platform. We're really excited about that. It's completely free for anyone to use and for anyone to become what we deem as Hashgraph certified. We also have this huge developer community on Discord. You can jump into that. Previously, what I did is I started a software company in Central Europe, which was a VPN service, and I got into this space when our customers wanted to anonymize their VPN transactions. VPNs, for those that don't know, help you unblock the web. Our customers wanted to be anonymous while using that. Sounds pretty nefarious, it probably was. And they would pay us in Bitcoin. We were one of the early companies to integrate BitPay as a payment processor. And that's the story of Buffered, and then sold that company and then joined this team full time. Back to the technology. The technology, what Hashgraph is it's literally not blockchain. So all together, we're all going to make a pact with each other that when we talk about blockchain, when we talk about what is now today known as blockchain, we're going to call it distributed ledger technology, right? Because it's really not blockchain. A lot of what you're hearing about in the space. IOTA is not blockchain. IOTA is a DAC, right? There's a lot of other data structures out there. A block is literally a chain of blocks, right? Hashgraph is literally not that. We are a graph of cryptographic hashes. It is a simple and elegant algorithm. It's mathematically proven. What that means is that we have a proof of what it means to have fairness and asynchronous Byzantine fault-tolerant security, the best you can do in a distributed architecture on our network. It is patented. This is the elephant in the room. You can ask me as many questions as you want after the presentation on this. We do not hide behind this fact, and we think it makes this project better. And I'll talk about why. And nothing we talk about today is theoretical. Everything is implemented in software. You can go and download this right now. You can use it for those that know how to. If you don't know how to use it, you can still use it because you can download the SDK and we have demo apps, including a game. And for those that are interested, I'll show you the game later. So I think that's pretty cool and that's pretty exciting. We're going to talk about the categories of consensus real quick, and I'll just blow through these. There's leader-based systems, there's proof-of-work blockchain, economy-based, and then this category that we call voting-based systems. These are our terms. When we talk about leader-based systems, I am referring to PBFT and Paxos and Raft. We can jump into why they're leader-based, and we will in a second. Proof-of-work, everybody should know POW, that's Bitcoin and Ethereum. Economy-based, this is what the market's trying to move towards, to scaling proposals like Casper. Voting-based, these are 30-year-old algorithms, which are really cool. This is what actually, this was the light bulb that sparked the innovation of the Hashgraph consensus algorithm. We'll do a quick slide on each of these, just so you guys know what we're talking about. And I think all of you will be sufficient blockchain experts after this and can go school your friends on the marketplace. So this is kind of exciting. Hyperledger Fabric, they're IBM's product. R3's Corda, this is from the R3 company. EEA, Ethereum Enterprise Alliance, Quorum. When we talk about leader-based consensus algorithms, these are what these systems are using. There's a leader in the system. Now there may be variations of this. There may be a round robin where the leader, the community comes to consensus on who's the leader, but there's still a leader for a point in time. It may only be 20 seconds, it may be 2 minutes, there's still a leader. And so long as there's a leader in the system, all the members, the minimum requirement here is all the participants of the community, all the nodes on the network must know the IP address of the leader. This causes a really big problem because a disgruntled employee or a hacker or someone that has access to a node with bad intentions could easily disclose the IP address of the leader. Anyone and their mother can go to DigitalOcean and get a bunch of droplets and create a botnet and DDoS this network and take this network down. It's fairly trivial to do a directed denial of service attack today. It's actually much less expensive than it used to be. So send a bunch of data packets here, take the network down, and then the network would respond by electing a new leader. But of course, you have to tell every node in the network the new leader's IP address, and this would be an arms race, right? This would be a constant fight to keep the network up. This is very inefficient, this is very vulnerable, but it does better throughput than proof-of-work blockchain. You're going to do Microsoft Cocoa, is based on this, IBM's Fabric, Hyperledger Fabric. You're going to do a couple thousand transactions per second. Really cool, actually. Really cool for POCs. I think this is great stuff. Proof-of-work blockchain. This is what the public network space is really dominated by in terms of market value. And the way this works, the minimum requirement here is that every participant in the network needs to receive every transaction. It's also really inefficient. What we're actually fighting for is we're solving all of these complex mathematical equations to win the right to add a new block to the chain. Now, a couple things happen when you win that right. One, when Kyle wins the right to add the block to the chain, Kyle gets to set the total order of transactions in that block getting added to the chain. Do we trust Kyle? He's a pretty good guy. I happen to trust Kyle, but many other people in the world won't, in knowing that he'll put Jordan's transactions or Manson Lehman's transactions at the top of that block and probably not yours, right? And that's not good because we won't have fair order or total order of transactions. The other thing is that this is really inefficient in that I may still be trying to solve the same computation that Kyle has already solved, but Kyle's already won that right to add his block to the chain. So there's an inefficiency here. It's massively expensive in terms of electricity requirements represented by that beautiful graphic up there. And it's also not, it's scalable to an extent, but I think Ethereum today is capping out when enough people are not playing CryptoKitties, you can get maybe 17 transactions per second on the network. Okay, so limitations, much more resilient to DDoS attacks. You DDoS one of these nodes, you will not take the network down. That's great, but it's not fair and it's not scaling really well, which creates problems in the marketplace. So that's proof of work. We have economy-based systems. This is our term, this is not the market's term. We call these economy-based systems, and we do it because these systems rest on a very important assumption, which we also happen to think is a flawed assumption. But I'll talk about why, but the assumption is that all of these nodes will do what's in his or her best interest to maximize the amount of money that they can earn by participating in the network, and Casper as a validating node. But the reason that's a really bad assumption is that software, or a virus, can easily force or compel a node to do something irrational. The real question we want to answer, period, in distributed ledger systems or distributed networks is, can one compromised computer disrupt consensus on the network? This does not sufficiently answer that. Lehman has done a great video at UC Berkeley where he talked about the class of attacks, and he goes into a lot more detail on why this class of attack, economy base, has still many security vulnerabilities. It's also not asynchronous Byzantine fault tolerant, and we can talk about why they've actually made up a new word for many of these economy-based systems, which always starts with probabilistic or ends with some connotation that means it's really not ABFD. So that's economy-based. I won't dwell too much on this because this isn't even deployed in the marketplace yet, and we can also talk about why we don't think this will scale after in Q&A. But I want to talk about voting-based systems, where if you go back 30 odd years, Dr. Baird found this whole class of academic research. There's actually quite a bit of thought leadership in the academic space on voting-based systems, which fundamentally have the best security possible in a distributed system. The requirement here is that every node on the network submits a vote. It's as simple as that, including the nodes that are offline. The problem with it is it has unrealistic bandwidth requirements. No one's ever deployed a voting-based system. Literally, no one's ever deployed it. You'd never come to consensus. But it has the best security properties. Theoretically, this is the way we could have it work. If everyone had the best bandwidth in the world and everyone were always online and connected, this is something that you would want to use. So the question became, how do you get the best security in the marketplace without the impossibility and the unrealistic bandwidth requirements which make this impossible to deploy? And that's where the breakthrough came, where Dr. Baird back in 2015 realized that by adding 2 small hashes to every event or every transaction on the network, those 2 transactions are who you last spoke with, the last transaction you received from this other participant on the network, and the last transaction in your local copy of the database. Okay? If you have these 2 cryptographic hashes, we would know what everyone else on the network knows. And we'd have this immutable audit trail of everyone that's talked to everyone else throughout the history of time. Thus, I would not need to ask Kyle, if I'm just joining the network, Kyle, what are you voting on the stated consensus? Is this true? Is this not true? I don't need to ask that yes or no question to Kyle. I already know everything Kyle knows because I know the last digital signatures in his local copy of the hash graph. By adding these 2 cryptographic hashes, some really cool things happen. Number 1, there's no need to submit a vote across the network. So we achieve the very best bandwidth we believe is possible because you're literally only sending 2 bytes of information. That's it. So we're really capping out in terms of bandwidth. Bandwidth is really the bottleneck here. Better bandwidth, the hash graph is going to go faster. Okay? So I'd start with that. So we're talking about, really, let's dive into this. We're talking about 500,000 TPS, transactions per second, in a single shard on our network. Don't know of any other project in the space that can claim that without some sidechain scaling solution or some ultra-sharded proposal. That's with 3.6 seconds of consensus latency, and yes, we are digitally verifying our signatures. It wasn't in the white paper. We're updating the white paper. We did not have the performance results there. For those that are interested, with digital signature verification, where you validate every digital signature, what that literally means is every time Jordan talks to Kyle, or Kyle talks to Brad from OpenCrowd, or Brad talks to Miles from Carbon, we memorialize those events, right? We memorialize those events, and those events need a digital signature to digitally sign in, right? Those need to be settled on a GPU, right? That's what we're doing. We're doing 1.18 million of those every second. So that's a huge, really we go back to consensus being the bottleneck here, but still 500,000 TPS is going to do pretty much anything you want it to do at this stage. You get your firewall resistance. What you also get is you get fairness. Inside an event, we have something called a timestamp, but it's not your timestamp because we don't trust you, right? We don't trust Jordan to submit a fair timestamp because I'm going to lie to you and tell you that I submitted my transaction before everyone else, right? You have an economic incentive to do that. What we have is we have a median consensus timestamp, where it's when the median is when most people in the community, the median of when most people in the community receive that transaction. And by working off that, we're able to enable a whole new genre of applications like stock markets and auctions and things where you need to know that total order. What I think is the coolest is gaming. MMOs really rely on heavy centralized infrastructure today. Some of the game companies we're talking to have $100 million plus investments in data centers, and it's a tremendous cost just keeping those things online. In the peer-to-peer web, you'd be playing peer-to-peer. There'd be no need for a game company to get all that infrastructure. That's really going to lower the barrier to entry for people that want to join this competitive game landscape and make these casual games. So I think that's pretty cool. this is a summary of the security of what we talked about: leader-based, voting-based, economy-based, just what else is in the market. You still want immutability? Great, we have it. Actually, we'll do you one better. We'll talk about controlled immutability in just a minute. We have DDoS resistance. Huge. I mean, DDoS attacks exist. We cannot operate businesses or platforms on the assumption that they don't. DDoS attacks took Netflix down. They can take CDNs down. We need to accept that DDoS attacks exist. It's really important to be resistant to those. We have fair ordering of transactions with fair timestamps. So let's talk about where we came from so we know where we're going. For those that were at the launch event, you've heard this already, but we always at Hashgraph talk collaboratively about the ecosystem. We think a lot of the other projects in the space that something we compete with have actually added a lot of value to the space. Whoever Satoshi Nakamoto is, he or she or a collective of people have done the world a service by, at scale, introducing us to this concept of distributed trust. Before Bitcoin, we really didn't know what distributed trust was, at least wasn't deployed at this scale. My favorite example of this was, I think it was back in 2012, there was some kid who got on College Game Day, right? For those that don't watch sports, like Saturday morning, ESPN, on College Game Day, huge poster that reads, "Hey mom, send Bitcoin," in a QR code, right? He's just waving this thing frantically. Someone on Reddit saw it. Reddit's the best community on the planet, right? Someone on Reddit saw it, optimized that image, and this kid gets $32,000 sent to his Bitcoin wallet address. This is back in 2012. I hope the kid kept some of that Bitcoin, right? It's a lot of Bitcoin. When you look at what really happened there, right? That's a fun example. But let's really talk about what happened there. We have people, complete strangers, perhaps on opposite sides of the globe, maybe in Dubai or in China. We're watching College Game Day and sending a complete stranger money without going through any intermediaries. No need to get out of your house, get in the car, and go to Western Union or MoneyGram. No need to talk to your bank and pay to a wire transfer fee. No need to use PayPal. No need to do any of these things and still send them money. No need to use Venmo. Venmo's huge in New York, right? No need to use any of this and send money to a complete stranger on the opposite sides of the planet. The ramifications of that are earth-shattering, right? Sending money to people without having to give it to the Red Cross, who, yes, they do a lot of good, but they also take 10 cents out of every dollar donated to them or something like that. Sorry, 9. Sorry if there's anyone from the Red Cross here.
I was kidding.
Okay, yeah. But instead of going through these organizations, we can donate directly to people behind we can say enemy lines who need it. If North Koreans could give us their QR codes, we could send them Bitcoin and maybe they could use that to buy food. This is already happening in Venezuela, where people are making border runs to Colombia to buy stuff. Really big deal. So distributed trust, we cannot discount that. What happened next is people said, well, with this, what is this Bitcoin thing? It's an application on top of this underlying technology that's really a ledger. What else can we do with ledgers? Turns out people are doing some really cool shit with ledgers. Sweden is trying to move title deeds to any property in Sweden onto a ledger. The Republic of Georgia over in Europe is doing the same thing. That's actually kind of groundbreaking too, because for those that haven't bought or sold property, it can take 40 to 60 days, in some countries even longer, to get ledgers to prove you even have the right to sell that house and no one has a lien on it or anything like that. So moving this on the ledgers, you'll be able to program a smart contract with a digital token that represents a title deed. You can program an atomic swap, a smart contract, to say, I'm going to send Bitcoin to this address, you're going to send your title deed to this address, and we're going to swap. That's going to change a lot of real estate transactions. That's going to be a multi-trillion-dollar industry long term as well. Lots of other cool stuff is happening here. Intellectual property rights, stock certificates, diamonds, provenance of stuff that we want to track over time. We have regulation coming sometime in 2020 here in the United States, where pharmaceutical companies are going to need to attest to every drug or every ingredient that's in their products and prove the origin of it. That actually also works in their favor, so they can prevent counterfeiting or black market pharmaceuticals, which represent in some countries more than 40% of pharmaceutical sales. So really big deal. Other people using these ledgers for other stuff. I just talked about smart contracts, but I would say that's generation 3 of distributed ledger technology. We don't trust each other. You have Bitcoin, I have a title deed to a property. We can now transact with each other. Before, you probably needed a real estate agent or a broker or another man, a middleman of some sort, escrow. You don't need that with a smart contract. Today, most people use these things for ICOs, right? Can't hate on that. It's really disrupting finance and the way people are raising money. Non-equity fundraising is a pretty cool thing. But there's a lot of other really cool applications to a smart contract. And I think we're just beginning to see those. And then the 4th generation, we say we're ushering in the 4th generation, and then immediately after we said that, Telegram says they're not 5th generation. So, you know, I say okay, but let's see the open network deployed. But that's neither here or there. The 4th generation, we believe, will be characterized by the fair ordering and fair matching of transactions. How do we transact with each other with trillions of dollars eventually coming onto these networks? How do we transact fairly with each other? We need commodities markets that are distributed. We need stock markets, and we need auctions that are going to help you sell title deeds. All of this is going to happen in the 4th generation, which is exciting. So just some use cases that we're already starting to see form because this is possible. We have people in our ecosystem building markets. One day those markets could resemble stock markets like a NASDAQ. You can do micropayments. Micropayments is a killer application. And I can jump into a whole bunch of reasons why, but micropayments enable you to do all sorts of stuff so that Jimmy Wales doesn't have to. Jimmy Wales, the guy who started Wikipedia, every 6 months he probably asks you for $2 or $3, right? If we had micropayments enabled natively in the browser, he could simply deduct a fraction of a penny, and you could pay to read a page on Wikipedia and not even know, not even feel that. If it's 1/100 of a cent, what do you care? But aggregate over the hundreds of millions of page views that Wikipedia has, that actually keeps them in business. So micropayments could disrupt what we think is a publishing model. That's just one example. Maybe you don't like that example, but Jimmy Wales at least wouldn't have to ask us for funds. What else did I want to say on this point? Micropayments, I'll leave it at that because I don't want to reveal too much here. But public ledger improvements with timestamps, we've got that here. Time-limited business transactions, you could do that. Which is great. Identity and session management, we'll talk about why we enable that on our platform. Games, as we talked about, eBay. A lot of this stuff is actually already built or in development now. You're only now hearing about some really exciting companies like Carbon that are coming out of the ecosystem and building some really cool stuff. But you know, again, some of this was actually built in 24 hours at a hackathon. Actually, Solomon, I don't know if you know, Solomon, the guy that won our TechCrunch Disrupt hackathon, showed up. You remember Solomon? Yep. He actually showed up to the San Francisco meetup we did last Friday, and Solomon built in 24 hours. I thought he was out of his mind and he was never going to finish, but he integrated Hyphenate, which is an SMS API, and created a distributed Christie's or Sotheby's. So all of us could be at home, and you could be watching this auction on TV, and you could send an SMS and send a bid to this auction, and the network comes to consensus on when the bids were received and closes the auction. It was remarkable. They built that in 24 hours, and we're like, holy shit, that's so cool. We had to, Lehman freaked out about it. It was great. So, you know, and I think that's like, whoa, we got to introduce you to the Christie's guys. If anyone knows anyone from Christie's or Sotheby's, you should tell them about that. But there's also collaborative apps. You could also use Hashgraph to frankly build a better Google Docs or a Slack or something like that. Now, that's the technology. The sexy thing to talk about now, and of course I'd be remiss not to talk about it, is the public ledger space. Those of you that are familiar enough with Hashgraph know that on March 13th here in New York City, in Times Square at the PlayStation Theater, we made a really big announcement that we're going to address what we see as the problems in the marketplace that make public ledgers pretty difficult to do today, because there's tremendous problems. Although the market's rallying, so for those of you that have been around for a while, it's been probably a pretty good day for all of you. But Hedera is our governance council and our solution to what we see happening in the marketplace and why we think that you need to solve these problems that I'm about to talk about before you release a public network. I also want to point something really important out. For the last 3 years, we've been privately focused on building an enterprise company. We've focused on building technology, getting enterprise traction, and then going out into the public marketplace. We think that's the right way to build a company, instead of just being hypothetical or releasing ideas in the form of a white paper and raising. This is real tech, you all can download it. And I think that's an important point. So what are the market requirements for public network adoption? Like how are public networks? And let's be real, right? If we're gonna be really introspective, I assume all of you are part of this blockchain DLT community at large, right? But if we really want mainstream adoption, if you want grandma to use it, and mom, and your aunt that barely knows how to use FaceTime, how are we going to get mainstream adoption of this technology? We have to solve a lot of problems. First, you have to solve performance. Bitcoin, if everyone on the planet used Bitcoin today, you'd never be able to send a transaction across the network. Fact. Let's just take Venezuela. If Venezuela became the shadow currency, as CNBC claimed earlier this year of Venezuela, it would take you a month to send a transaction across the network. That's just Venezuela, right? I mean, every family could go buy groceries once a month. We must accept that as fact. We need to get better technology in the space. Lots of people are trying to address that, including us. So you also need security. You're never going to get trillions of dollars of value onto these networks when it seems like every week we hear about some hack or some vulnerability or some backdoor into some exchange or some code. But more importantly, security of your own assets. Security of the fundamental properties of the network. We need deterministic platforms, and there's no deterministic platform in the space today. Everything is either non-deterministic or probabilistic, or something that doesn't have asynchronous Byzantine fault-tolerant security, as we learned 30 years ago, is the best you will ever achieve. So security, governance, and when I say governance, I want to be really clear here. I'm talking about the legal and the technical controls required to keep a stable platform. That's governance, and then of course stability. I'm going to talk about the patents, okay? Open source communities are great. We believe they're great. We think that the fundamental value of an open source community is the economic incentive is if we're all developers in this room, everyone in this room contributes their best lines of code, and the whole community benefits. The high tide raises all ships. It's great. Open source technology is great. When you combine it with a cryptocurrency, everything gets flipped on its head. The economic incentive is for all of us to come together, create Bitcoin Nomad right here in this room right now. We should do this actually as an experiment. We're going to create Bitcoin Nomad. We're going to do an all-night hackathon, and in the morning, we're going to fork the Bitcoin main chain. We can do that. We can do that tonight, right? We can fork the Bitcoin main chain, and in the morning, we can have Bitcoin Nomad and be public on the marketplace, hijack the brand, claim that we are Satoshi's vision, and this is what he always wanted, or she always wanted, or the collective always wanted, whatever. That's what we're seeing happen in the marketplace. This is the problem with open source and cryptocurrency. I fundamentally believe in the value of cryptocurrency and the ethos of the problems with big government. We get that. But we also need to grow up and accept that while anarchists are great catalysts for change, we need proper governance in this industry if we expect grandma and mom and aunt and everyone to come on board and use this technology. And that's what we're trying to solve for. So with this, our solution is the Hedera Council, which is the Hedera Hashgraph Council. It's a geo-distributed body that's geo-distributed across the entire planet. Every continent will be represented on this council. Every major industry vertical will also be represented on this council. We have representation from FMCG companies and telcos, some of the largest financial services organizations, some of the largest law firms on the planet, a couple of the big four consultancies. We are completely distributed across the planet and completely distributed across every industry vertical. This is a council that instills the trust of the mainstream. The other thing I'd mention about these companies, who are they? They're best in their respective classes. Best in class in terms of revenue. They're global giants of their respective industries. And they all have these blue chip brand names that if we were playing one of those logo quiz games that you often see people play on the airplane where they show you part of the logo and you're like, oh, who's that? You gotta guess it. Everyone in this room is gonna know the names of the companies. We find it highly unlikely that an Australian food manufacturer would collude with a European telco company. They've got no incentive to do that. This is the purpose of the platform. Now, what is the platform actually doing in terms of this? They're enforcing a set of legal and technical controls. What are those? They are votes on when do we upgrade our wallets. So who makes that decision? Let's talk about this. Is it a benevolent dictator? Is it Dr. Lehman Baird? Is Dr. Lehman Baird the new benevolent dictator of the blockchain space? Dr. Baird has a new breakthrough. We are upgrading our wallets. Well, I think if Dr. Baird were here, he'd be the first to admit you that you shouldn't trust him to be making really great software updates when he's 99 years old, and we should probably have a governance body in place. What about continuity? What about a real process for all of this? So the members vote on that. The members have their experts on a technical council. They contribute their best developers. They look at the source code, which is open for all to see, and I'll talk about that in the next slide. But they vote on when do we upgrade our software updates. This is a really cool part about Hashgraph. We all decide that on this Friday at 9 p.m. Eastern Time, we all upgrade our software. The upgrade gets gossiped out to everybody across the planet at the same moment, on the same day, at the exact same moment in time, we all upgrade our wallets. You prevent a fork by doing that. Anyone without the upgraded software is not going to be able to rejoin the network and earn money by participating in consensus. That's a really big deal. No one's doing this in the space. So that's kind of cool. That's a technical control. The other legal controls, the patent is open for you to use. Here's the catch. You cannot use the patent and deploy your own public network. Okay? We are not hiding behind the patent. There is, and I think this is really important, there is no license required to use Hedera Hashgraph. Carbon, did you guys get a license from us?
No.
Great. Happy to hear it. Open crowd. Have we ever had to give you a license to build something? Great. There is no license. You just go build. Okay? You go build. What you build, you own. Okay? It's your source code. Our platform is completely open source for review purposes. You can see the source code. You are never making an API call against a black box. You will always know what that algorithm is doing and where it's sending your API call. You will even know who's settling the transactions. All of this is possible. So you don't even need to talk to us. The software you develop is yours. And that's kind of cool that you never have to talk to us because probably you don't want to talk to me because I talk a lot, right? So that's also really exciting. Just go build, and we're building the self-service suite that you will be able to just go ahead and do that. So I mentioned this is a really important point, and then the other is transparency of the code base, right? Again, it's completely open review. We have code bounties now. People in our developer community actually just recently found new bugs in it. Fixed it. The new SDK has this bug, has the changelog you can see has this bug that those guys in the Discord community found, and that's handled. We will be taking this to hackathons. There will be many eyeballs on the code base. We will even go so far as to say that if you have a pull request, a developer has this really great piece of code, they want to suggest we merge it into the code base, great, send it to us. The governors will decide if that gets merged. Not Lehman, not me, not Kyle. Real experts on the subject matter that know what they're talking about. So there's that. The Hedera Public Services. What is Hedera? Hedera is literally a chaotic organization. It is a for-profit company that is owned by the 39. Swirlds is just one of the 39. Hedera sells a set of services. Okay, that's the business. The business is we sell services. Here's the cool part about this business though. This business allows all of you to get paid by running this business. And here's how it works. It's kind of cool. You all have an economic incentive to put a node on the network. Hashgraph is completely open consensus. Anyone will be able to throw a node on the network, including a stay-at-home mom down in Sydney, Australia, and she'll probably be able to make her car payment, or maybe even more, pay her rent every single month. I don't know what real estate prices in Sydney, Australia are, but I went with the car payment. I think that's pretty safe. So you'll be able to make some good amount of money. You scale out the number of GPUs you have and the number of machines, you'll be able to make money by gossiping about gossip on Hedera. Now here's how you're compensated. You're compensated by help for your node to be providing this set of services. Okay? You are also compensated by lending your CPU cycles to the network, your bandwidth, your storage, and that's what you get compensated for. Your bandwidth, your storage, and your CPU cycles. Now you're compensated as a function of how many coins you have in your wallet. Yes, Hadera is a proof of stake public network. Now the way we do proof of stake is obviously the more coins you have in your wallet, the more money you're going to make. If you don't have any coins in your wallet, you're probably not going to make a lot of money. And that also, I'll talk about why, because that's a security property that gives you ABFT in a public network. So your cryptocurrency. I don't like to think of it as a cryptocurrency because that confuses a lot of people. People just want to speculate, they just want to say, cool, let me go buy this new Bitcoin. How about we talk about it like micropayments as a service? That you can send someone across the globe a fraction of a penny. You're never going to be able to do that in Bitcoin. The transaction fee is like 20 bucks. So why would I send Kyle a tenth of a cent if it's going to cost me 20 bucks to send him a tenth of a cent? So we're ruling out a whole genre of use cases. There's a lot of reasons why we'd want micropayments in the future. Maybe your electricity company, instead of charging you monthly, will charge you every time you flick on and off your switch, although that would be really annoying. But you know, there's just crazy different things that will happen. When your robot vacuum cleaner wants to talk to the microwave, I don't know, maybe there's some micropayment being exchanged. There's lots of actual cool use cases, besides those silly ones I just mentioned, that I think would be really groundbreaking. File storage, we have a distributed file store. You're compensated, or you pay, if you're the buyer, you pay per byte per second, okay? That's how this works. I like to think of it not as a file store, but as a file directory, where what you're really storing is a cryptographic hash that references a file that could be stored on a CDN, a content delivery network, or somewhere that's not on the ledger. It could probably get pretty expensive if you had really big files on here, but if you want to use it that way, you could. You can also encrypt everything you put on here, and then this gets sent out to the nodes. We all gossip it out. Does Kyle have enough money in his wallet to pay per byte per second? Great, we all update our state. We all update the state of the ledger. Great, it's in our local state. Cool, so that's the file store. There's a lot of really cool, groundbreaking things about this. I'll tell you the biggest one now is our Revocation Service. Has anyone here heard of GDPR, the new identity regime, or the new, great, so you've heard of GDPR. Let's talk about what GDPR is, because many of you didn't seem to know what that is, but that's okay. It's in Europe, so it doesn't affect you yet, but it's a regime that is general data protection regulation. This is part of the reason why Zuckerberg is in Congress right now, testifying in front of the House and the Senate. What has he done with all of our personal data? The European Union got kind of smart and just started making laws about the thing, right? This is what you can and can't do with someone's data. They're actually more forward-thinking than the United States on this, right? I think we're way behind the times. In Europe, you have the right to be forgotten. In Europe, you can go to Facebook or Google and say, delete everything you ever knew about me. That's kind of cool. If someone publishes something really bad about you on Google, or you want to just see a search result of this, you could probably get Google to take that search result down and just have yourself completely forgotten, which is a lot of reasons why you would want to do that. In identity, you need a revocation service. So I don't want to scare anyone here. Our cryptocurrency application, people are storing the local record of that. You will have complete immutability. Probably for cryptocurrency, we want this immutable audit trail of every time anyone's ever sent money dating back to the genesis of the network. Yep, that's good, okay? In identity, in our personal data, we probably don't want that. That's a really bad idea. What if someone stores child pornography on the network? You probably want to delete that right away, right? Right away. And you want to prove that it's deleted. We have a system for doing that. We have this revocation service where once the file's put there, you will be able to actually revoke that file. Let's talk about identity too. Let's say a DMV wants to have a DMV application on top of Hedera Hashgraph. Not saying they're doing this, by the way, but it would be a pretty good idea. They would issue you a credential. The credential comes from this KYC AML certificate authority. In this case, the DMV is the certificate authority. And Kyle's belligerently driving down the road, neglecting people's lives, and he gets pulled over, and we're probably going to want to revoke his driver's license, or at least freeze it. You're going to want to revoke that credential. Someone tries to scan it and reference it in the ledger. It doesn't exist. You shouldn't be driving. That's revoked. If he gets caught driving again, they'll know he has a suspended license. There's really practical ways to do things like that and to revoke a credential. And I think that's really important for identity and who you share it with. So these are the services. This is familiar to all of you because this we borrowed from the marketplace. The market has adopted a set of Solidity standards where people are using ERC20 tokens, where people are using Solidity scripts. I actually got a demo of this working the other day. It is mind-boggling. It actually works through a REST API, which is just a browser-based interface where you can copy and paste a CryptoKitties ERC script and execute it on Hashgraph. No need to worry that you're going to suck 30% of the entire network utility that's available or to congest the network. You can use Solidity and execute your scripts and get all the properties of Hashgraph running through the Solidity virtual machine here, the Ethereum virtual machine. So that's an open source code base. If there are Solidity developers in the marketplace today that know how to code ERC20 tokens, you can take those ERC20s and execute them here. So I think that's kind of cool and kind of groundbreaking. All of this sits on top of the Hashgraph SDK. And this is on top of the internet, TCP/IP, and what we're exposing is a set of public APIs where you pay, much like an API business, you pay to use these services. So you want to send money to someone, you want to send a token to someone, you would pay the gas price, as it's called in Ethereum, you'd pay the microtransaction. Here's a cool thing about on Hashgraph, the microtransaction, the network is as close to free to use as possible, where we're literally talking about fractions of pennies that you are paying as the gas price to execute the network. And even if the price of the native platform token increases by orders of magnitude, that is still negligible when you're paying a millionth of a penny or some fee that, unless you were doing millions of TPS, you're really not going to feel. So this is all of this is really kind of cool. In the future, there probably will be other services, but this is what we have today. And that really wraps up Hedera and Hashgraph and Swirlds. So I think we should open it up to questions, or I'm happy to shut up and just drink a beer.